Hey everybody. So we're getting into 8.4 today, mid-segments of triangles. Before we get into it, go ahead and get the title here, copy this slide, and we'll see what's going on. Okay, so let's just read this little definition over here. It says a mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. Every triangle has three mid-segments. Okay, so taking a look over here on our example triangle, let's just kind of point out what it's saying. So it's saying the midsegment of a triangle connects the midpoints of two sides of a triangle. Okay, the midpoints of the sides. Let's point that out. So if I were to look at this side length right here, the midpoint of this side length would be this point M. Okay, by the way, the reason why I know that's the midpoint is I can see that it's directly in the center because it's cutting the side length into two congruent halves. Okay, so that's a midpoint. Over on this side length, P would be a midpoint because again, it's cutting this side length into two congruent halves, and so would M. Okay, so those are the midpoints of the side lengths. A mid-segment connects those points. Okay, so this line right here, segment MP, would be considered a mid-segment. All right, and then same idea, this segment right here, MN, would be a mid-segment, and then that segment right there, NP, would also be a mid-segment. Okay, so that's the idea. That's what a mid-segment is. And obviously you can see that there are three of them, just like the definition said. Okay, so yeah, it connects the midpoints. And just remember, the midpoints divide the side length into two congruent halves. Okay, so this is what this lesson's all about today. So let's jump into it. Okay, so the first thing we're going to get is what's called the mid-segment theorem. All right, go ahead and copy this, and we'll figure out what it's saying. Okay, so let's read a little definition here. It's saying the mid-segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. All right, so we're getting two things out here. They're telling us that the mid-segment is parallel to the third side and is half as long as that side. All right, so let's just take a look at our picture over here. Okay, right on this thing, it's only showing one mid-segment, but just remember, this applies to all three of the mid-segments. So what's going on here is this line right here, which by the way is a mid-segment. Here's the two things we know. We know it's parallel to this third side. Okay, remember those arrows mean that it's, parallel, which by the way, that's what this is saying right here. DE, the mid-segment, is parallel to AC, this side length. Okay, and we also know that the length of this mid-segment is half the length of this side length. Okay, so for example, if we knew that this side length was 20, we would know that our mid-segment would be half that, 10. Okay, we also know the opposite would be true. If we are given the mid-segment, say this was 15, we would know our side length would be double that, 30. Okay, and that's basically what this little formula says right here. So, make sure you're getting this, especially this little formula here is pretty important. What I would do, put a little box around this formula because it's a big thing that shows up a lot in this lesson today. Okay, so yeah, basically the mid-segment equals 1/2 of the side length. Okay, so yeah, this is our kind of our big thing here. So let's use it to do an example. Okay, so go ahead, take a minute, copy this, get the triangle and everything, and we'll answer these questions together. Okay, so first things first, it's telling us that UV and UW are mid-segments. All right, so first, let's just make some sense out of that. Let's highlight those. So UV, they're telling us this line right here, as well as UW, I'm gonna make it a different color. This line right here, they're mid-segments. Okay, actually, I'm gonna make it blue just because I'm gonna use red to make my markings. Okay, so those two things are mid-segments. Here's what we know by the fact that those are mid-segments. And I don't know if I'm gonna use all this information, but it's worth getting on the triangle. Okay, if these are mid-segments, I know that U is a midpoint, which means that it's dividing this side length into congruent halves. This is congruent to this. Okay, and the same thing is happening over here. V is a midpoint. That means this is congruent to this, and same idea here. W is a midpoint of the side length. That means this segment is congruent to this segment. Okay, it's not necessarily information we're going to be using to answer these questions, though it'll come up. But it's something that's worth always putting on because it's free information. Okay, so now that we know that, let's look at number one. It's asking us to find UW. Okay, so it's asking us to find the length of this blue line right here, this mid-segment. Okay, well, here's what we know. We know that this midsegment right here is, I guess, first of all, parallel to this side length here. Okay, but more importantly, we know that the length of this midsegment is half the length of this side length. Okay, so if we wanted to write out a little formula, it's not terribly necessary, but it's worth putting in your notes. We know that UW equals 1/2 of this side length, which they've given us the length 10.2. Okay, so all we have to do is take half of 10.2, which you could use a calculator or you could just do it in your head, 5.1. That is the length of UW. Okay, and I guess technically, segment UW. Okay, so there's our answer. Or if you want to write it over here, you can. Okay, so yeah, there's a lot going on here, and these problems can be confusing just because there's so much on the triangle, but we need to just really break down the basics and know, okay, mid-segment was half the length of this. Easy enough. Okay, let's look for RT. Okay, so RT, let's go ahead and highlight it. RT is this side length right here. Okay, and here's a couple things we know. We know that this side length and this mid segment that I highlighted in green, UV, are parallel. Okay, so that's good. Doesn't really help us, but the other thing we know is that UV is half the length of this side length. Okay, so if UV is 5.6, we know that this side length is going to be double that, right? And I'm trying to think of the way I want to represent this. If we wanted to write an equation, it might not be worth writing an equation because it might make it more convoluted than necessary, but let's do it anyway. Here's what we know. UV equals 1/2 of this side length, let's call it RT, okay, which is what we're looking for, right? Okay, we know UV on this one, it's 5.6. Okay, equals 1/2 of RT. All right, I just want to point out, this is not necessary right here. If I want to just take 5.6 and double it, 5.6 times 2, which again, if you want to use a calculator, I'm going to do that real quick because I don't want to mess up. It gives me 11.2. Okay, that's my answer. Okay, 11.2. All right, and over here, same thing, 11.2. But what I want to point out is this equation is doing the same thing. Technically, when we go to solve for RT, we would get rid of 1/2. Okay, and if you guys remember, to get rid of fractions, we just multiply by the reciprocal. Okay, the reciprocal is just flipping the fraction. So 1/2, if I multiply that by a 2/1, okay, I can also, I also want to do that to this side. Remember, 2/1 is the same as 2. Okay, so 2 times 5.6 would give me an 11.2, and these would cancel out and give me RT. Okay, so this was the longer way of figuring out that the side length was 11.2. I wanted you to see that, but this equation was probably unnecessary on this problem. As long as you realize, oh, mid-segment's half the side length, so the side length is double the mid-segment. If you want to use that rationale, I encourage you to do it. Okay, but sometimes the equation is good to have. Sometimes it's necessary. Okay, last one, the measure of angle SVU. Okay, let's find where that angle is. Remember, when we name angles with 3 letters, we're starting on its side length, going around the angle to the other side. So angle SVU, that's this angle right here. Okay, so this is what we're looking for, this angle right here. Okay, so I'm looking through this and I'm thinking, okay, what other angles do I have? I have this one, this 41-degree angle. Okay, how can I kind of make a connection between this angle, 41 degrees, and this one? Well, here's where the parallel lines come into place. I know that these blue parallel lines, or sorry, these blue lines are parallel, which, by the way, let's show that by putting little arrows on them. Okay, I'm going to put this arrow here. Okay, they're parallel. Okay, if you guys notice, these two parallel lines are being cut by a transversal. All right, and this goes back to the stuff we were learning in what chapter was that? Like chapter 4, maybe chapter 5, I forget. Okay, but yeah, if you guys notice, these angles on alternate sides of the transversal on the interior of the parallel lines, these are alternate interiors. Okay, which is important to know because we remember alternate interior angles are congruent. If this is 41 degrees, this is 41 degrees. Okay, and there's my answer. Okay, so yeah, anytime we see parallel lines, you should probably think, I'm probably going to get some congruent angles. Sometimes they would be supplementary, but normally they're congruent. Okay, so yeah, a lot going on here, but don't overwhelm yourself on this problem. These were actually really easy. I kind of went into too much detail probably. Okay, let's keep moving. Okay, so I'm gonna have you guys try a problem a lot like this. Go ahead and draw this new triangle and try to find these three lengths here. Give it a try. Okay, so first things first, we have some mid segments. So let's highlight the mid segments. Even before I get into these, here's what I know. MP is a mid segment. I can see that because it's touching the midpoint of this side, the midpoint of this side. Okay, and PN is also a mid segment. Okay, so let's take a look. We're asking us for JL on this first one. JL is this side length right here. Okay, well, here's what I know. This mid segment, which is 39, is half the length of this side length. Okay, so in other words, if this is 39, I know this side length is double that. All right, so literally, we could write out the equation, but I don't think it's necessary. I think we can just take 39, double it, and get our answer. Okay, and it looks like we're going to get 78. Okay, so please don't overcomplicate these like I kind of did on the last example. I just really wanted you to wrap your brain around what you were learning. Okay, let's take a look at number 2. It's asking for PM. Okay, PM is this mid segment. Okay, and we know there's a relationship between this mid segment and this side length right here. Okay, again, we know that this mid segment is half the length of this side length. Okay, so if this side length is 95, we know that if we take half of it, or in other words, divide it by 2, we're going to get our mid segment. Okay, and yeah, the calculator helpful. Looks like we're going to get 47.5. Okay, so just kind of realize these two problems, they're working forwards and backwards. One of them asks for the side length given the mid segment. One of them asks for the mid segment given the side length. Okay. All right, last one. A measure of angle MLN. Let's highlight it. MLN. So there's M going around L to N. Okay, so this is the angle we're looking for right here. Okay, so let's look to see what do we know as far as angles are concerned. It looks like we know this angle right here. Okay, it's 105 degrees. All right, so you might already, after I highlight it, it kind of becomes more obvious what's going on here. But let's point out what's going on. These lines we know are parallel. Actually, let me make them red. Okay, these are parallel lines, right? Okay, which if you wanted to, you could put little arrows on just to show that these are parallel. Okay, and this blue line here is a transversal. Okay, so I'm looking at these two angles and I'm realizing, oh, these are on the same side of the transversal, same side of the parallel lines. Technically, they are corresponding angles. All right, but more importantly is to realize that that means they're congruent. If this is 105, this is 105. Okay, there's our answer. Okay, so yeah, this is, just look at the math that we did here. Multiply by 2, divided by 2, and got congruent angles. These are actually really easy problems. They're just very convoluted when you look at them. Highlighting stuff like I'm doing is, I think, really helpful. If you can do that on your notes, highly recommend it. Okay, so let's keep moving on. Let's try these examples where they're actually asking us to solve for, a variable on this, n. Go ahead and copy these two. We'll try it out. Okay, so on these problems, first thing to realize is that this, on number 1, 6n, is a mid segment. All right, and a couple things. We know it's parallel to this side length, but more importantly to this problem, we know that this is 1/2 the length of this. Okay, so when we go to do these problems that give us, stranger values, we need to actually write the equation. Okay, so let's go ahead and do it. Again, we know that the mid segment, 6n, equals 1/2 the length of this side length, 48, which I'm going to put in parentheses because it's being multiplied by the 1/2. Okay. There's our equation. Okay, from here we're just solving. Okay, which gives us kind of nice numbers. We got a 6n, half of 48 is 24. Okay. Dividing both sides by 6 to solve for n. Okay, looks like n is going to equal 4. Okay, and I'm just double checking, is that what they wanted us to do? Find n? Yeah, so we're done. Okay, cool. Number 2 is the same idea. We want to make an equation out of this. Just kind of notice though, the variable on this one was, on our mid segment. The variable on this one is on our side length. Okay, but when we go to write our equation, we're doing the same thing. We're taking our mid segment, which is 11.3, and we're saying, okay, that's equal to 1/2 the side length, which is an n plus 4.2. Okay, so it's a little different on this because our variable's ending up, inside the parentheses here, but we're using the same idea to make our equation. Okay, so here's what we need to do. I guess there's actually a couple things. Normally, when a number's outside the parentheses, we, apply it to both things in the parentheses, right? We could do that, and we would still get the right answer. But here's another thing. Fractions, I don't like to deal with fractions if I don't have to. So I'm going to do what we did before, just kind of flipping back real quick on this here. And to get rid of the fraction, I'm going to multiply by the reciprocal. All right, it's something we can do. So I'm going to multiply this 1/2 by a 2/1. Okay, and whatever I do to one side, I have to do to the other. Okay, and basically just to kind of show you these 2/1s, if I were to multiply these together, 2 times 1 is 2, 1 times 2 is 2. I get a 2/2, which turns into a 1. Okay, in other words, an invisible 1. It kind of disappears. Okay, that's why we're doing it. Over on the left here, this is just a 2, right? So my calculator, 2 times 11.3, oops, did it wrong. Sorry. Okay, is 22.6. Probably could have done that in my head. But yeah, there we go. So I'm getting 22.6 on the left, on the right. These are gone. If you want to cross them out, and we're left with this n plus 4.2. Okay, last thing, solving for n. Need to get rid of this 4.2 by subtracting it, 0.2. Okay, from both sides. Okay, so 2.6 minus 4.2 gives me 18.4 on the right. Got n. I'm going to flip it around. So n equals 18.4. Okay, so the big thing is making sure you get your equations written out. And again, it always follows the same pattern. The mid segment equals 1/2 the side length. Okay, so with that in mind, I'm going to have you guys go ahead and copy these triangles and write out the same equation. The mid segments, n plus 2, equals 1/2 the side length, 6n. And then solve for n. Do the same thing for this one. I guess we'll call this number 1 and this one number 2. Okay, give it a try. Okay, so yeah, let's go ahead and do it. Our mid segment, n plus 12, equals 1/2 of our side length, 6n. Okay, made that too big. Okay, cool. So I'm taking a look at this. Here's what I'm thinking. If I multiply 1/2 times 6n, I get a nice clean number. I get rid of the fraction. So I'm not going to multiply by the reciprocal here. I could, and I would still get the same answer, but I'm going to take 1/2 of 6n because I know it's easy to do. Okay, so I got an n plus 12 on the left. Half of 6n is a 3n. Okay, now I have variables on both sides. I'm going to choose to bring this n over to the right. Okay, so I got a 12 on the left and a 2n on the right. And now dividing by 2, let's see, let me bring this up a little bit. Okay, solving for n, getting rid of the 2 by dividing, it looks like I'm going to get 6 equals n. I'm going to flip it around and write it as n equals 6. Okay, going over to number 2, same idea. I know that my mid segment, 4n plus 9, equals 1/2 of my side length, which is 14n. Okay, on this problem, I could do the exact same thing I did on the last one. I could take half of 14n and get a 7n, but just to show you that it still works, because you've already tried this on your own, we should still get the same answer. I'm going to multiply by the reciprocal of this, all right, and we'll see what happens. So I'm going to do it differently. I'm going to get rid of the fraction by multiplying by 2/1. I also have to do that to the left-hand side. Okay, here's a big thing. This 2/1 needs to be multiplied by the entire left-hand side, not just 4n, but all of 4n plus 9. Okay, just by the way I'm doing it right now is making this problem probably more difficult than it needs to be, but I just want to show you that it still works. Okay, so I'm going to now distribute that 2 into the parentheses. So 2 times 4n is an 8n, 2 times 9 is an 18. Over on the right, these are gone. I have a 14n. Okay, now I'm going to bring my n's to the same side. I'm going to choose to bring this 8n over to the right. Okay, so I've got 18 on the left, 14 minus 8 gives me a 6n. Okay, now I can divide both sides by 6. 6 goes into 18 3 times. I'm going to get 3 equals n. I'm going to flip it around, n equals 3. Okay. So no matter which way you did this problem, if you took half of 14 and got a 7n and then solved for n, you should have still gotten n equals 3. Okay, I just wanted to make a point there. All right, guys. So yeah, that is mid-segments. Not too shabby. The algebra gets a little strange, but making your equations, not bad at all. Okay. So yeah, I'll see you guys later. Bye.